In this lesson, we're going to start learning some basic toolpath creation. To get started, make sure you open the supplied dataset MCU 2D Mill Lesson 5 Basic 2D. This is the same file that we carried on from Lesson 3, so feel free to use your file or open this file. Both are exactly the same. Once we have the file open, let's navigate to the Toolpath tab and Tool Manager. Inside of here, we're going to start by selecting all the tools inside of our current machine group. We're going to right-click and we want to delete the tools. Next, we want to click Open and navigate to the supplied location of the dataset. We want to open up the file MCU 2D Mill Tools. This is a tool database file that we've provided with the course. If we expand this, you'll note that there are 14 tools in here of various types and sizes. These are all set up as assemblies, which mean that they have a holder as well as a tool. And we'll explore that in a little bit when we start to create our toolpaths. We want to select all 14 of these tools and push them up into our machine group. We won't necessarily be using all of these tools, but we want to make sure that we have them inside of our machine group to access if we need them. These are going to be the 14 tools that are considered inside of our tool turret on our machine that we're using. Let's go ahead and say OK. Now that we have our tool manager set up, we can start creating our first tool path. We're going to start by looking at a 2D contour. We can get to this a couple different ways. First, we can right-click at the insertion arrow inside of our toolpath group 1 inside of our toolpath manager. From here, we can navigate to Mill Toolpaths, and we can go down to various aspects such as contour, drill, pocket, etc. From the toolpath tab on our toolbar, we also have a 2D section. If we use the drop-down arrow, notice that we have milling, hole making, as well as some manual options. Inside of milling, we have contour, and we also have dynamic mill and dynamic contour. We'll be exploring the dynamic operations a little bit later. For right now, let's select contour, and note that we're starting with a chaining operation. If we take a look at our chaining options, we're currently set to solids with a 3D radio button selected. Next, we have options for complete loops, single edges, linked edges, or partial loops. We also have a face option. If we select the face option and rotate our part around, we can select the entire bottom of the face, but notice how this also picks up on the small holes inside of our part. So we're going to clear our chain, and instead of the face option, we want to use a full loop, and we'll want to select this lower edge. Once we do that, we'll get a preview on the screen showing the entire loop. Select the green check mark, and let's OK this operation. Once we come into our 2D toolpath options, note that we can change the toolpath type inside here as well. We have it set to contour, but we could also change it to pocket, dynamic facing, slot mill, or model chamfer. We're going to carry on with our 2D contour. When we navigate to the tools section, notice that right now we have all of our tools that are loaded in our machine group. 1 through 14 are all here and available for us to use. We can also select a library tool. If we select that button, we have the available option to open up a new library if we need, or filter our active tools. Let's go ahead and expand the tool name area so we can see what tools we have available to us. There are several ball end mills, flat end mills, as well as bull end mills. Let's select tool number 8, which is a 1/2 inch flat end mill, and say OK. Notice in here that it tells me that we have a similar tool already exists in our list. And that's because the Select Library tool is trying to add it to our current list. We're going to go ahead and say no, and select the green check mark. The difference between what we see here and what we see in the Select Tool Library is displaying directly from our library, and in here we're seeing everything that's directly in our Machine Group 1 from our Tool Manager. So you see a green check mark next to Tool 8, and we can also see its parameters on the right-hand side. I'm going to add a comment in here that says 2D contour. This comment can be displayed inside of our toolpath manager, and it might help organize things a little bit later on. Next, let's take a look at the holder section. Because we are using a tool assembly, we also have information about the holder that's being used. This is great because it helps us check for collisions and make sure that we're not running into additional geometry, such as this raised section around the outside. So right now we have this information, and if we need to, we can change the projection amount. The projection amount is how much the tool is extending outside of our holder. There are various ways that we can modify the tool projection, but let's go ahead and make this 3.25 inches, and notice that it modifies this value. Let's go to our cut parameters. Right now the compensation type is set to computer, and we're going to set this to where. Next we have a compensation direction. This will determine which side of our selection the tool will be on, whether it's the right or the left. We can also compensate to the tip, but in this instance it's not going to make a difference for our toolpath. Our contour type is set to 2D, but we can also set it to ramp. This means that it'll follow our 2D contour, but it'll ramp down at a current 3-degree angle until it gets to our depth. We have infinite look ahead set by default, and we'll leave that turned on. We have some various values for talking about breaking corners and radii, and we're going to leave those as default. And we also have a stock to leave on walls and a stock to leave on floors. For our specific example, we'll leave these at 0, but if you want to do a finishing pass, it's a good idea to leave a small amount of stock on the walls. Let's go ahead and navigate to depth cuts. Notice that currently depth cuts are not turned on. If we go back to our cut parameters and change this to 2D, we have the available option to turn on depth cuts. This will allow us to determine how much we want to step down each pass and ultimately go down to a final finishing step. Let's go ahead and use our depth cuts, doing a max roughing step of 0.25. We'll do one finish cut at a final depth, and the finish step will be 0.05. I'll also use the keep tool down option to make sure that the tool isn't retracting to its clearance plane every time. In our lead in and lead out section, this will determine how the tool enters and exits the stock. In our case, we want to tighten these values up a little bit. I'm going to set this value to 0.1. We'll set the arc to 0.1 as well, and we'll push these over to the exit amount. The sweep angle determines how much of a change in direction it's going to have as it enters or exits a stock. I'm going to reduce that to 30 degrees, and I'll push that over to the exit as well. On breakthrough, this will determine how much past the bottom of the part we want to allow the tool to go. In our specific case, we're not taking into account the holding of our part. We'll focus on that a bit more when we get into our next lesson on dynamic 2D operations. Right now, we simply want to understand some of the basics. So we'll use a breakthrough amount, and we'll have it extend 0.1. Multiple passes is similar to depth of cut. Depth of cut will dictate how much we step down in the Z direction each time. Multiple passes will dictate how far away from the part we are in the X and Y direction as we make our cuts. Let's do an initial rough cut, and we'll do one finish pass. We're going to leave all the settings as default for feed and speed, but notice that we do have various options, such as spring passes, to make sure that the material hasn't flexed at all. This is especially helpful if you're dealing with thin wall parts. We're also going to do the finish pass at only the final depth. This will save us time so we're not repeating the finish pass constantly. This is good in our instance because our specific tool is tall enough to do a final pass on the area of concern. We also will use keep tool down. Lastly, we want to talk about linking parameters. Our linking parameters will dictate where the tool is, where it starts from, and where it's going to end. We're going to start by using a clearance plane of 0.1, and this is going to be absolute. We're going to set our retract rate to incremental, and we're going to set that value fairly small at 0.05. We're going to set our feed plane incremental, and we want to set it to the retract value. So we'll set this at 0.05 as well. For our top of stock, we're going to use 0 and associative. When we use associative, we'll have to select a point for the top of our stock. Lastly, we want to set the depth. The depth is going to be based on our contour. We're going to use associative again, and we'll select the bottom of our part. The depth can also be left as incremental to be calculated off the chain value. For instance, if we use incremental value of 0, the bottom of our part where our contour will be cut is at the bottom edge of our part where we selected our contour. You would want to use associative if the contour selection is not at the same depth or you need to pick an alternate location. There are various other options inside of this in all toolpaths, and we'll try to do our best to explain them as needed. For example, the tab section allows you to determine small amounts of material on the side that you want to leave when you're cutting an outside contour. This is helpful if your part is held in a vise and you need to leave a small amount of material so it doesn't drop out. For right now, let's go ahead and say OK and create our toolpath. One thing we'll instantly note is that this toolpath is situated on the wrong side of our contour. This means that we have to do one of two things. We can either go into our geometry chain, we can select our chain, and we can reverse it. If we modify the chain by reversing it, we change the orientation of these two green arrows. The smaller green arrow is dictating which direction we're cutting. If we say OK, and then select to regenerate all dirty operations, our contour is now on the outside. We could also go into our parameters, into our cut parameters, and change which direction our compensation was set to. But for right now, this will work out just fine for us. Go ahead and save your file so we can move on to the next lesson.